to today's STERIS Tech Talk on the Radiation Technology Centre service offering. STERIS Tech Talks are a series of webinars covering subjects relating to gas and radiation sterilisation processing and the laboratory testing and validation services which support these processes. My name is James Warner and I'm the Marketing Communications Manager for STERIS Applied Sterilisation Technologies. I'll be the host for today's session. Our presenter today is Daniel Howell. Daniel is the European RTC and UK Laboratory Operations Manager for STERIS AST. He has held roles in various disciplines, including but not limited to project, sales, operations and technical across all sterilisation modalities in his 5 years at STERIS. Daniel is responsible for ensuring technical, operational and service excellence across these facilities. Daniel is also involved in industry organisations such as ASTM and the panel on gamma and electron irradiation. All attendees are on mute for the presentation. However, we would like to encourage everyone to submit any questions using the questions function, which you can find on the GoToWebinar control panel. Questions will be answered following the presentation. Today's presentation will be recorded and uploaded to our STERIS AST YouTube channel. Please note that continuing education credits are not provided as part of this webinar. So now over to Daniel to begin the presentation.
Thank you, James. Some introduction, so I hope I can live up to it. And good morning, everyone. So, as James stated, today's presentation will be about the Radiation Technology Centre, basically the service offering that we provide across the globe. And from here on out, probably you'll hear me really referring that as the RTC. It's quite a mouthful, so I'm not going to keep saying Radiation Technology Centre the whole way through the presentation. So going to be about the RTC and really how we utilize those across the group, the services we offer, and how you can start to utilize them yourself. So James already introduced myself, so that will be this morning's session. There'll also be a session this afternoon with Joe Hurd, who's essentially my counterpart in the States, and he'll be giving the same presentation as well. In terms of the agenda, relatively straightforward. So we'll be going through what. So what is the RTC? Why? So why should you utilize the RTC and why do we have RTCs? Where are they located? How do they work and how can you use them? And then we'll summarize the session at the end. Obviously, then there'll be a question and answer section at the end as well, as James said. So we'll start with the what. So in short, RTCs specialize in the radiation processing of non-routine samples at high precision, high quality, and at a rapid turnaround. Now, I think probably the most important question that you're going to ask straight off the back of that is, what do we really mean by non-routine samples? And just to dive into that a little bit more. So essentially, this is more just of an industry term. We talk about routine processing, we talk about non-routine processing. And for routine processing, so if we start there, that's really where we'd be talking about probably a validated process, which is high volume of product usually going through contract sterilization to the market. And that could be hundreds or thousands of boxes or pallets a year. Whereas when we talk about the non-routine processing, we're generally talking about a relatively small number of samples or products. Those samples may have very specific requirements, which may not have previously been validated. A lot of them are actually validation activities themselves. And really the purpose of the RTC is to take these processes, these products, and put a dedicated facilities and dedicated people in place to make this non-routine become routine for those facilities and for that service. And if we just dive into the org chart on the left a little bit so we can detail some more of what you might be expecting. So if you look here, when we look into validation activities, things such as max dose testing, and then really the two on the right that are encompassed by verification doses, really a minimum dose testing. So the minimum sterilization dose you need to make your product sterile, or the maximum dose that you can give it without affecting its functionality. So ultimately, those validation activities will be needed before you can even go to routine processing, or maybe needed on an ongoing basis, such as a dose audit, to make sure that the process is still validated. Aside from those, then we have kind of a catch-all in what we call R&D, or research and development, and that's really everything else that you may want to do outside of that. And again, it could be things that are necessarily outside of the sterilization industry as well. So if we think a little bit more on the minimum and the maximum dose work, probably a common question that we get, or a common assumption, is that that work would have to be done in the same facility that you would be doing your routine processing in. And that's not the case, and we'll talk about that in a little bit more detail later on. But when you're talking about these validation activities and these validation processes, the important thing to note is really those tests are establishing a relationship. So with the minimum dose, you're establishing a relationship between this dose and the microbiological burden, bioburden on there, really how much dose is needed to make that sterile. And that is the same relationship, whether that's established in one facility or another. Similarly, with the max dose, there's a relationship between that dose and functionality. So as long as we can measure the minimum and maximum doses that we can give the product, it doesn't have to be done in that same facility. Now, that is somewhat different when you're getting to dose mapping and process qualification, but we're not going to be kind of covering that today. So with the minimum and maximum dose work, obviously it's very highly linked to our testing services. So if that's some work that you're looking to do, not only can we offer the dose work, but we can obviously link that directly to the actual testing services, which will complement that. So if you're doing some minimum dose work, or you're doing a dose audit, obviously we have microbiological testing labs as well. So we could do that as a one-stop shop piece, where we can apply the verification dose, and we can do the associated bioburden and sterility testing at the labs as well. And you don't have to send that to two separate places. We'll handle that process for you if that's something that you're looking to do as an all-in-one. Similarly, if you're looking to do maybe some max dose testing, potentially on the product or the packaging, again, we have a testing laboratory where we can provide some of that testing as well, so that you know that at that max dose, for example, is the packaging still integral, or what's the shelf life of that packaging, and many other tests you can see they're listed there. Or I suppose the catch-all really then would be if you were doing a brand new product, you're bringing a brand new product to the market, you don't have the minimum dose or the maximum dose, and you need to do a full validation, irradiation. And again, we can encompass that really all in one with the lab work, the minimum dose and the maximum dose, and then the testing associated with it. So really it could be kind of a one-stop shop where you can get everything all together. So that's a little bit of the what we do. So now we'll move into, I suppose, the why. So why would you utilize it, or why would we have these facilities? So we talked a little bit before about obviously the precision, the quality, and the turnaround. I think the most important thing to note here is it's really about providing all of those in parallel. And to be able to do that, obviously, it's very specific requirements that we need. And so what we do is really in what we would call the foundations of that service is we would have very specific equipment. So we talk about the capabilities of our equipment. So those were really bespokely designed for this type of processing. So again, to make sure that we're giving that precision, quality, and turnaround. The processing methodologies that we have. So really all the way from operational qualification through to then the actual ongoing processing. That's really set up and designed with the RTC, the min and the max and other type work in mind. So it's really set up for that type of processing and that type of processing only. And lastly, obviously, we talk about the experience of our people. So The staff obviously that work there are very familiar with the type of work that you'll be looking to submit. This is what they do day in, day out, all the way through from submission to the actual receipt, going even through to the packaging configuration to the certificates. This is really what we do all day. So like we were saying, taking that non-routine and making it routine for the RTC service, really to give you the best service as part of that and to make sure that we can achieve the precision, quality and turnaround that you request. So I suppose to look into a little bit more detail on those pillars, here's just probably some examples or case studies, you could say, and there's lots more, but just a couple that I kind of picked out on each one. So we'll start with precision. So why would you want precision? So start at the top. If you're doing a verification dose, so either as part of a minimum dose establishment or a dose audit, it could be a regulatory requirement. So again, you're often going to hear probably the phrase plus or minus 10%. And if that's the type of dose that you were looking to achieve, you'd probably have to be thinking, if you were looking to do that on a routine facility, that could be very difficult or impossible to achieve. Again, those routine facilities are really set up to do in high volume processing, much bigger dose windows as well. Whereas these facilities are really designed to do those tight dose ranges. And I think one thing probably to think about as well is obviously that is dependent on the product itself and the type of radiation source. But the one thing that we know obviously is that the actual equipment itself is set up to give you the best opportunity of achieving that dose. Probably one interesting question, which could be food for thought, is plus or minus 10% even a requirement or not? And again, it's very, very commonly used in the industry, and there's a reason why. But probably a question to ask yourself, is it even actually a requirement when you're doing that type of testing? Secondly, if you go to the opposite side, we talk about some of the max dose testing again, or even some research and development. We talk about reducing the risk of false positives. And really what I mean by that is if you're coming into, for example, and you want to validate a maximum dose of 50 kilogram, and then maybe let's say you want to do that on an industrial routine facility. They say no problem, we can process that, but maybe they want to process that at 50 to 75 or 50 to 80 kilograms. That's fine. When you do that test then, and potentially that product fails, did it fail at 50 or did it fail at 80 kilograms? That's not something you're going to be able to know. That dose range is something that you accepted. That tolerance is something you accepted as part of that process. So the 50 kilogram max dose failed, but you don't know where in that range it did fail. So if you wanted to be a little bit more specific, or if you wanted to try and hone in a little bit more on where the actual max dose is, you may want to do a tighter dose range. So for example, then you do the same test at 50 to 55 or 50 to 60. Then if it fails, you know it's failed in that very short window. Or then that same test could then pass, which may have meant that just that the tolerance that you allowed before actually caused the failure. So potentially a false positive for that 50 kilogram max dose test, just because of the amount of tolerance that you allowed on the dose window in the first place. So if we go on to quality, obviously right first time, and obviously everyone wants everything right first time, so it probably sounds pretty obvious, but it can be a little bit more, I suppose, of an issue if you're doing some routine development or you're doing some sample work. So first of all, maybe if you're in development or design stage and you have a limited number of samples, maybe it's a new product coming to market, or maybe it's just a small amount of samples that you have, but you still want to test them. So obviously you can't afford failures. It was not possible to repeat it. But also things such as, you know, a lot of the time you may be requested to do trial samples first to establish areas of the process. For most of our products and processes, really, it's a little bit different in that, in most cases, not only will we be able to tell you if we can achieve that in advance, and if not, we'll work with you to make sure that we can achieve that before the product arrives on site. And we can do that pretty much on a theoretical basis for most of the technologies, just based on the operational qualification. And then again, we could work with you to make sure that that is achievable before that arrives. But also, a lot of the time, we don't require trial samples. And again, there are exceptions to that. But in most cases, we could get those samples on site and process them straight away to your dose requirement without needing anything extra, and make sure that we have the confidence in achieving that the first time. Secondly, and obviously somewhat limited, if you're doing a study, maybe again, it could be a new product validation, or it could be some testing. The last thing you're going to want, again, is those additional trials or additional repeats, which you may not have taken into account in that larger program. They could delay a project. Ultimately, they could potentially delay a product launch, obviously, which no one wants. Lastly, as a case study, we'll talk about the turnaround. So again, we talk about we offer an expedited request depending on the dose and the number of samples, really from sample receipt to a certificate in 24 hours. So if there's something that you need to get through urgently, again, maybe it's a dose audit that you need to get in this quarter, or maybe it's just some testing that you need to do ASAP to gain some confidence in something. And again, that's something that we can help with and really expedite those requests through. Or perhaps you have very specific study requirements. Maybe there's a certain number of days before something needs to go on a radiation, or a certain number of days after radiation something needs to go on test. It's something we're seeing a lot more now, particularly in relation to dose audits and the timing between, for example, from manufacture to the irradiation, and then irradiation to the actual testing. And this is really related to an aspect of 11137 Part 2, where it talks about that time period reflecting the routine manufacture. And the reason that is in there is if you think about if you're doing bioburden testing and you're doing a microbiological test, the dose audit obviously is trying to establish that the actual routine process is working. So if the timings don't match, and then the bioburden is changing over that time, either decreasing or increasing, is it actually reflecting it? Is it more of a challenge, or is it less of a challenge? Obviously, the latter probably being more of an issue. So that's really why that's there. And that's probably something to consider when you're establishing that process. And if you need to look into those timings, even if I suppose it's not required, it's something that you may want to know. And if so, obviously that's something that we can help with. Okay, so where are the RTC locations? And I'll not go into everyone in great detail, but you can see there on the map where they're located in Europe and in America. I think really the most important note is that within the Americas and within Europe, we offer all three radiation technologies, so E-beam, gamma, and X-ray. So Liverpool has all three in Americas. Then we have E-beam in Tullamore and Radeberg. We have gamma in Bradford, McCool, and Radeberg, and then X-ray in Daniken. And I think just a note on there as well is each of these facilities has, so in some cases, bespoke and specific requirements as well. So again, if you come to one facility and it's something that we can offer in the group, obviously we will communicate with our counterparts, and we can, I'm sure that somewhere within the group, or even if we have to go across the pond, then I'm sure that we can meet those requirements. So dive a little bit more into some of the most recent expansions. So two of the items on there just most recently had expansions at the end of last year. So first of all, the Bradford RTC, which is a gamma facility, opened just towards the end of last year. Some pictures there on the left. Obviously, we'd ideally love to have you on site for a tour, but current circumstances, it's not the easiest thing to do. And really, just some of the key, probably highlights of that. So we talk about product handling and configuration, which we talked a little bit about before. So you can see there at the receiving station, we essentially have a workbench. And one thing that we do when we receive the product, again, through working with the customer, and obviously with the customer's permission, is we'll essentially open that and we'll assess that packaging for how it's packaged in terms of achieving the best dose uniformity that we can address that. So the best precision. So again, even once the product's on site, we don't just necessarily take it and put it in. It's something that we're going to work through using our experience and the setup that we have to make sure that we really optimize that precision for every product individually. So each one is handled completely bespokely. It's an incremental precision processing. It really means that when we're doing the dosing, again, we usually do that in multiple passes. We have kind of validated scheduling software really to calculate those timers. And that's really part of that, what we talked about before with the in situ dose mapping that we're utilizing there. So you can see slightly in the picture there, we have multiple different turntables and lots of dose rates. Each turntable actually can move. So again, closer or further away from the source to vary the dose rate. That could be to change turnaround or maybe to change the dose precision that we're achieving across that. That can have an effect. Or it could be that you require very specific dose rates for a certain test. Again, that's something that we can achieve there. In terms of generally, what kind of dose rates, again, we can go lower than 1 kilogram per hour all the way up to greater than 7 kilogram per hour. It really depends on the type of product, again, that we'd be looking at, but just as a high level. And then we talk about low dose processing. So again, in terms of the smallest dose we can give at once, we could give a very small dose to less than a kilogram. Really by setting small timers in there. Again, we don't have many other aspects to worry about rather than just a small timer on those turntables, and we can achieve very small doses either on an augmentation process or just actually if you require a very small dose in the first place. So over to the right-hand side, we look at Libertyville. So Libertyville already had an existing gamma facility. So actually, the Bradford gamma facility expansion is based on the Libertyville design. Whereas most recently, at the end of last year, they expanded to add E-beam and X-ray also. So again, you can see some pictures there of the conveyor, the beam, etc. So it's a single accelerator with a scan horn and an X-ray converter. With the X-ray at 7.5 MeV, 80 kilowatts, E-beam at 10 MeV and 30 kilowatts. And the beam energies can actually go up to 12 MeV at lower power levels for testing. Okay. Perfect. So as I said before, ideally we'd have you on site to give you a tour. It's quite difficult probably to visualize how the product actually goes through the process somewhat, particularly maybe on the turntables and on the conveyors. So we have here just a little animation video, hopefully to help visualize what that might actually look like in terms of the actual box in the process. So I'll just play this. Okay, so as you can see, obviously quite generic, but hopefully you can see there then when you're talking about the E-beam and the X-ray, obviously that's a conveyor that then passes in front of those scan horns with the product. And then when you're looking at the gamma process, That's a turntable that's sat directly in front of the source, and we actually rotate that product so that we get obviously even distribution of dose on all sides of that product. Okay, so for the last piece, we'll talk about how. So how can you actually utilize one of the RTCs? How would you start? What's that process look like? Where are you involved? Where are we involved? So from a high level, so in terms of if you're actually going to do a submission to us, so we have an online submission portal. So you go through there, ask you some questions about the actual test requirements that you're looking to do, and also which location and which technology you're looking to do that. And then probably comes the important piece. If you can get that far at the beginning, then we review. So we review every single submission, and that's going to go through a technical review as well as then ultimately commercial. So what we'll go through there is we'll go through those requirements, and there's many things that we're going to be checking. One, for the dose that you've requested and the type of product, can we achieve that? So as we discussed before, we want to know that we can achieve that in advance. So we're going to be doing some assessments to see if we can achieve that dose range. And again, it will be very upfront if we think that that's not potentially the case, and we'll work with you to see if there's any adjustments we can make to make sure that we can achieve that. Similarly, one thing that we do is, again, for very common tests such as dose audits and max dose, this is something that really is the bread and butter of what we do. So if there's any glaring potential mistakes, obviously we'll discuss that with you. If you submit something that doesn't seem to, maybe the test type and the dose doesn't seem to quite add up, then of course we'll come back to you. We'll just ask the question. Ultimately, obviously we'll process it to whatever requirements you would like. But again, we'll just see and just engage in that conversation just to see if there's something that maybe just potentially went wrong, that was a mistake on there. We don't want you to waste your time and money if there was just a mistake on there. Really, then going into the last stage, or sometimes this stage can come first if there's a lot of the questions you don't know. Obviously, we're always happy to have a call to discuss what it is that you're looking to do before we get to that submission. Have some brief, we can go through some brief understanding of what the actual processing would look like, maybe even getting into some details of whether we can achieve that, or if there's some very bespoke requirements, it may be something that needs a call regardless. Obviously, I put on there with the video chat, just as we more and more now, I think we're all probably very much used to having video calls. So that's probably most likely how that would look. And again, that could be post-review if there's some questions that we have, or it could be right at the beginning if you're not quite sure how to even get started. And we can help you look at what it is that you're looking to do and how that might actually go through to fruition in terms of actually getting that testing and making sure, I suppose, ultimately that you get out of the test what it is that you're looking to achieve. So again, that's a lot of the time when we're asking about the test type, is really just trying to get an understanding of what it is that you're trying to achieve to make sure that that test is set up to give you that answer. So on the other side, what if you're already doing your dose audits in another facility? Maybe you're doing those dose audits, so there's minimum dose pieces, or the min dose establishment, those dose audits, and you're doing those in another facility, you're not using an RTC. And maybe you want to transfer into an RTC. Again, that's something that we're there to help with. Obviously, the RTC has very close links with the tech team, who are our radiation experts across the group. And again, particularly when it comes to then diving into the standards of what's allowable and just really trying to highlight in terms of what that transfer would look like, it's something that we can collaborate with them and yourself on to try and help you through that process. In general, there's just a little bit of a pictogram here on the left to highlight some of the main considerations. So I mean, from a high level, in most cases, and there is an exception there, you can see at the bottom, from gamma to gamma, E-beam to E-beam, X-ray to X-ray, it's not necessarily an issue. And it's pretty straightforward and usually allowable under the standard. One consideration that you do have to take with E-beam and X-ray, there you can see at the bottom, is if there is water in the liquid state in those products, then there's some specific requirements that you may need to look into in more detail, a little bit less straightforward. But again, we can point that out, and more than happy to have a further discussion about that if that's something that has come up for yourselves. And just to finish, and then we'll go into the questions. So summary. So we talked about the what, the non-routine becoming routine for the RTC service. We talked about the why, so the high precision, high quality and rapid turnaround, and providing those all in parallel. We talked about the where. So obviously you can see you have global technology neutral locations. And lastly, we talked about the how. Obviously we went into some details with obviously for your specific test or your specific requirements, you can just contact us to discuss further. A lot of these things, particularly when it's studies and research, is much more of a collaboration, and having that discussion is probably the easiest way to get started, and our team will be standing by ready to discuss what it is you'd be looking to do. And that is the end. Thank you very much.
Thank you again for joining us today. This concludes the webinar.